Right. See, as a part of applications of derivatives, we completed tangents and normals. Right. Now, I am going to discuss mean value theorems. Mean value theorem, and specifically Rolle's mean value theorem. Right. We usually write it as RMVTH. Intermediate mean value theorem, IMVTH. Lagrange's mean value theorem, LMVTH, and Cauchy's mean value theorem. And these mean value theorems are much important coming to the exam's point of view, as well as these theorems help us in solving different equations as well as in analyzing the graphs of different functions, right? And since we completed tangents and normals, the concept of tangent for a curve helps here to establish these mean value theorems, right? Initially, we are going to start our discussion on mean value theorems with Rolle's theorem or Rolle's mean value theorem, right? See, first of all, look at this statement. I will discuss the proof for the Rolle's theorem, then different type of applications related to the Rolle's theorem, and maybe in the next class I will discuss intermediate mean value theorem and the other mean value theorems. So here, as a part of mean value theorems, I am going to discuss the statements of the each and every mean value theorem along with its geometrical interpretation and the proof derived from the geometrical interpretation, that in the sense proof of these theorems from the graph, and then some applications based on these mean value theorems. That's our plan to discuss in these mean value theorems. So first of all, Rolle's theorem. You just look here, what is the statement of Rolle's theorem? Okay. See, I am erasing this for the space concern. Whereas here coming to the Rolle's theorem, what it states. See, if you observe, initially we need a function f of x. As per the Rolle's theorem, f of x is a function, and that function is continuous in the interval ab, and that function is differentiable in the interval ab, and f of a is equals to f of b. F is a function which is continuous in a particular interval, which is differentiable in the interval, and f of a is equals to f of b. In such cases, there exists at least one c in the interval ab as f dash c is equals to 0. At least one c. At least one c in the sense there may be more possibilities for that c also. Okay? Right. See, as they mentioned, f of x is a function, and usually we will discuss all real functions. F of x be a real function. That in the sense you just consider the domain and codomain of that function is a real number, and if the domain and codomain is real numbers, then easily we will sketch its graph. First suppose, see, this is x-axis. So since it's a real function, the domain is this x-axis. See, we need to identify the interval AB. Somewhere we have A on this x-axis and somewhere we have B on this x-axis. See, what Rollstheorem states, if there is a function satisfying these three conditions, then only there is a chance to find such a C in that interval as f dash of C is equals to 0. F dash of C is equals to 0 means what? F dash of C is equals to 0 means C such that in the sense f dash of x is equals to 0 for x is equals to C. Is it right? The derivative of the function is 0 at x is equals to C. That means, in other words, we say that C is root of f dash of x is equals to 0. C is the root of f dash of x is equals to 0 because C satisfies that f dash of x is equals to 0. Okay, right. See, Rolle's theorem states that if a function is available satisfying these three conditions, then for sure there exists at least one root for the derivative of the function. That is the statement of Rolle's theorem. Then there exists at least one C, maybe more than one also. Okay, possible in the interval AB as that f dash of C is equals to 0. So the proof is very simple, very clear. When you think about the graph of a function satisfying these three conditions. So for that, just here I am going to give you the graph. I am going to mention the graph of a function which is satisfying these three conditions. For that, initially I took x-axis as the domain of f of x, and I am going to identify the interval a b. So somewhere I have a, somewhere I have b. The first condition is what? F is continuous in the interval a b. F is continuous means the graph of f is continuous. F is differentiable in the interval a b. That means at every point in between a b, derivative exists for the given function. And f of a is equals to f of b. See, first suppose this is a and this is b, right? Somewhere at a, the functional value is what? See, while sketching the graph, what we do? X and y is equals to f of x. If x is equals to a, its value is f of a. So at a, maybe the graph point is here, and here the point is a comma f of a. And at b again, usually the functional value is f of b, but as the given f of a is equals to f of b, with the same height you need to locate b comma f of b. Why with this same height? Because f of a means y coordinates, so vertical length. F of b means y coordinate, vertical length. Since f of a is equals to f of b, y coordinates are same, these lengths are same. Right. Now, graph of f of x for sure passes through this point as well as for sure passes through this point. Now I am going to sketch the graph of f of x. That graph is continuous in between these, that means the graph is in between these two, somewhere the graph is there, and for sure the graph passes through these points, and the graph is differentiable and continuous. So maybe one possibility of the graph is this. Since the graph passing through this point as well as this point, then in the sense for sure the graph rolling in the sense turning. For sure the graph turns to pass through the other point. Once again I will tell you. See, there are many possibilities here. First, suppose here is f of a point, take it as a. Here is f of b point, take it as d. I am going to sketch the graph in between these 2 points such that the graph is continuous. So what are the possibilities? One possibility is this. Other possibility may be this. And some other possibility, this is point A and this is point B. I may sketch the graph like this, passing through this point, take a turn, and passing through this point. There are many other possibilities, not only 2 rolls, rolling in the sense turning, as I said, rolls, okay. Rolls means it turns like that, okay. That in the sense the graph rolls, and that's why we are calling it as Rolle's theorem. It's very obvious thing. There is no any other possibility. From this point to this point, if you wish to sketch the graph passing through these 2 points as a continuous graph, no other possibility is there. Either like this or with 2 rolls. Somewhere you may sketch not only 2 rolls, maybe more than 2 rolls and 3 rolls also. But for sure the graph rolls once. Maybe it may roll more than once, but for sure it rolls once. If it rolls once, at a point where it is rolling in the sense, as I said, turning, at a point where it is turning, at that point, if you sketch the tangent, that tangent is parallel to x-axis. If it rolls like this, at this point, if you sketch the tangent, that tangent is parallel to x-axis. If it rolls twice, at these turning points, if you sketch the tangent, those tangents are parallel to x-axis. Since tangents at these rolling points, at these turning points are parallel to x-axis, slope of this tangent is 0. Right? Slope of tangent means what? Derivative of f dash of x at this point. So this point is our C. Somewhere at this point the graph is rolling. So this point is our C. C is in between A and B like this. At this C, the derivative of the function is 0, so f dash of c is equals to 0. If it turns like this, corresponding to this point, there is some x value, that is c. If it rolls twice, there exist 2 possibilities for c, c1 and c2 we say. If it rolls thrice, there exist 3 possibilities for c. It depends on the graph. But since the graph is passing through these 2 points, as the question says, as the statement says, for sure there exists one roll, for sure there exists one turning, for sure there exists one c at which the slope of tangent is 0. That means for sure there exists one c in the interval such that f dash of c is equals to 0. Since f dash of c is equals to 0 at least at one point of c in the interval ab, that in turn represents that derivative of f is 0 at least for one value. That in the sense f dash of x is equals to 0 has at least one root in the interval. That's the statement of the Rollestheorem. See, application of Rollestheorem involves in identifying the solutions of f dash of x is equals to 0 or the number of solutions of f dash of x is equals to 0. But before going to apply that Rollestheorem, we need to check whether the given function is satisfying these three conditions or not. And according to Rollestheorem, we need to identify few things. First thing is, Rollestheorem is applicable only if the function is satisfying all these three conditions. Then only we will apply, right? If it fails in satisfying any one of these three conditions, then don't use this Rollestheorem. Don't apply this Rollestheorem. As well, if these three conditions are okay, then we need to conclude this. If this statement is okay, then we can't conclude these three statements. That in the sense, converse of Rollestheorem is not acceptable. Whereas one more point is, this C, there exists more than one C. Okay, sometimes there exist two possible values for C or sometimes three possible values for C. Right? So these are some precautions where we need to memorize before going to use this Rollestheorem in solving different problems. So finally that's the statement, and the proof is very simple with the help of the graph. As per the name of this theorem, Rollestheorem, in the sense the graph at least rolls once, and this Rollestheorem is not belongs to the modern mathematics. This Rollestheorem is there from the ancient times. Okay, see, Indian mathematician Bhaskara II already mentioned this Rollestheorem in his works. That in the sense, this Rollestheorem is also very ancient and traditional one in solving the different mathematical equations and in finding the number of roots for the mathematical equations. Right? So just have a look, and I will give you some problems related to the Rollestheorem. Before going to solve the problems, you need to get an idea about the statement as well as the proof, or you may say the geometrical interpretation of the Rollestheorem. Have a look. Look at first simple problem on Rollestheorem. We need to check whether Rollestheorem is applicable for the function f of x is equals to x square minus 6x plus 5 in the interval 2 to 4. If yes, find C such that f dash of C is equals to 0. First of all, we need to check whether the Rollestheorem is applicable or not. Right? See, to check the applicability of the Rollestheorem, we need to check these three conditions. Okay? And what is the first condition? F is continuous in the interval AB or not. See, we know that x square minus 6x plus 5 is a quadratic whose shape is parabolic. So for sure it is continuous everywhere. Since it is continuous everywhere, and for sure f is continuous in the interval 2 to 4. Right? If you have any doubt, just check the functional values of this f of x with different values in between 2 to 4. Always you will get a value, and for sure it is continuous. And the next condition is whether f is differentiable or not. See, what is the derivative of f of x, which is, as I mentioned here, f dash of x is equals to 2x minus 6. This 2x minus 6 exists, okay, in the interval 2 to 4. For every value in between 2 to 4, this f dash of x exists. That means f is differentiable. Second condition is also satisfied. And the third condition is f of a is equals to f of b. Whether it is right or wrong, we need to check. See, just calculate the value of f of 2. 2 square minus 6 into 2 plus 5. 2 square minus 6 into 2 plus 5. 2 square is what? 4. 4 plus 5. 9. 9 minus 12. Minus 3. And then what you say about f of 4? F of 4 is equals to 4 square minus 6 into 4 plus 5. 4 square is 16 plus 5 is 21, minus 24 is equals to minus 3. That means f of 2 is equals to f of 4. This is also okay. Here we are checking whether that Rolle's theorem is applicable or not. That means we need to check first three conditions. Condition 1 is acceptable, condition 2 is acceptable, condition 3 is also acceptable. Therefore, Rolle's theorem is applicable here. Okay. Check whether the Rolle's theorem is applicable or not. If yes, Rolle's theorem is applicable here. Since our answer is yes, now we need to find the value of C such that f dash of C is equals to 0. If our answer is yes, if yes, find C such that f dash of C. What is f dash of C? See, the derivative of this function, let some C. So the derivative already we found it as 2x minus C. So f dash of C is equals to 0 means 2C minus 6 is equals to 0 and C is equals to 3. So find C. The question is about finding C and our value of C is 3. That in the sense, this particular function is continuous differentiable and f of 2 is equals to f of 4 and the graph of this function rolls at the point 3. Okay, at the point where C is at the value of C the graph rolls. So at C is equals to 3 the graph rolls and the question is about finding such C. The value of C is 3. There is the problem. So for almost of all the problems we need to check these three conditions first and then we need to solve the problem using the additional statement. Okay, just have a look. Yeah, one more problem. Again we need to examine the applicability of this function f of x is equals to 1 minus x minus 1 power 2 by 3 in the interval 0 to. We need to check the applicability of Rolle's theorem. So first of all we need to check these three conditions. See, just check whether Rolle's theorem is applicable or not. No need to apply Rolle's theorem. We need to check, that's enough. See, to check whether it is applicable or not, we need to check these three conditions. First condition is continuity, second condition is differentiability, and third condition is f of a minus f of t. Right, as I said, first condition, to check the continuity for different values of this interval, f of x exists. First thing is, f of x always exists for the interval 0, 2. Since it is always exists for the interval 0, 2, f is continuous. And I will check the third condition first. F of a is equals to f of t. I will calculate f of 0. F of 0 is what? 1 minus 0 minus 1 power 2 by 3. So what is its value? Minus 1 power 2 by 3. So first you just apply square and then power 1 by 3. So its value is 1. 1 minus 1 is 0. And then what you say about f of 2? F of 2 is equals to 1 minus 2 minus 1 power 2 by 3. Again 1 power 2 by 3 is 1 and its value is 0. From these two, easily we will say that third condition is also acceptable. Third condition okay, first condition okay, then think about the second condition. See, for second condition we need to think about the differentiability of the function in the interval. For that you just calculate the derivative f dash of x. Derivative of 1 is 0 minus x minus 1 power 2 by 3. So minus 2 by 3 into x minus 1 power 2 by 3 minus 1. So something power n into x power n minus 1. So this is equals to minus 2 by 3 into 2 by 3 minus 1 means minus 1 by 3. Minus 1 by 3 means 1 by x minus 1 power 1 by 3. This is f dash of x. And now if you observe, the denominator has x minus 1. Since denominator has x minus 1, at x is equals to 1, this value not exist. That means f dash of x not exist at x is equals to 1. Since at x is equals to 1, f dash of x not exist, then we will conclude that f is not differentiable in the interval 0 to 2. Why? Because 1 is a number in this interval. At that number the function is not differentiable, so f is not differentiable. Since f is not differentiable, second point is not acceptable. Okay, so second condition of the Rolle's theorem is not acceptable. At the end, Rolle's theorem is not applicable for the given function. First condition, continuity is okay. Third condition, f of a is equals to f of b, okay. And the second condition, differentiability of the function is not acceptable in the interval. So Rolle's theorem is not applicable for the given function. That's the problem. Have a look. Just look here. Again, very simple. Actually, nothing is there here to solve. We have a function f of x is equals to sine bx, and interval is given as in between 0 to 2 pi. The question itself is saying that the function is continuous in the interval, and the question itself is mentioning the function is differentiable in the interval, and the question itself is mentioning that f of 0 is equals to f of 2 pi. And these three are the three conditions of Rolle's theorem. So for this problem, Rolle's theorem is acceptable because the three conditions are directly given in the question itself: continuity, differentiability, and f of 0 is equals to f of 2 pi. Then find b if f dash of pi by 2 is equals to 0. That's the thing. And f dash of pi by 2 is equals to 0. Okay. See, f of x is equals to sine bx. Then what you say about f dash of x? Derivative of sine bx is what? Cos bx into b. And as they mentioned, f dash of pi by 2 as 0. So what you say about f dash of pi by 2? b into cos b into pi by 2. And that is given as 0. This is equals to 0. And since this is equals to 0, cos b pi by 2 is equals to 0. If you send this b that side. So cos b pi by 2 is equals to 0. Then what are the possible values of b pi by 2? Cos of something is 0. Cos of something is 0. Whenever cos of something value is 0, cos 0 degrees is 1, cos 90 is 0, okay, cos 270 is also 0. From there we will get the possible values of b are 1, 3. Is it right? Cos 90 degrees is 0, okay. B value is 1 by 3. We need to find out the value of b. See, according to this Rolle's theorem, one more thing is, then find b such that f dash of pi by 2 is equals to 0. Okay. The possible values of b are 1, comma 3. Then there ends the problem, right? The possible values of b are 1 or 3. Look at the board. 3b. Next problem on Rolle's theorem. You just try to solve this problem. Okay. Function is given and Rolle's theorem is applicable for the function. Try to get the value of alpha. Okay. And in the next class, I will start my discussion on Rolle's theorem or mean value theorems with the solution of this problem. That's for the class. Thank you.